Hey everyone, how's it going? Welcome to the stream. Let me just adjust this. Okay. All right, so I think I got that right, sorta. Anyway, all right, so since the last stream, we were working on fixing the abnormal call stack returns. So I actually went ahead and cleaned up the changes that I had made during the stream and committed them here. So yeah, it turned out to be, I did a little bit of cleanup of, over the changes I made last time, but overall it's pretty much the same thing. The one thing that I did decide on was that when an abnormal return is detected, that I output it. Oh, hey, Jono, how's it going? So yeah, I have this thing where, if I detect abnormal returns, I actually output detected abnormal stack frame exit. And I can actually show you that here, just to demonstrate. So let's say we just double check that we are indeed set up to run Bedlam. So let me build and run that. And I can show you what that looks like right now. All right, so let's see here. Okay, I'm just gonna break for a second. Just wanna do some, I'm just gonna delete all my breakpoints right now. Okay, so actually there's my detected abnormal call stack. I'll just remove my breakpoints. All right, so if we break, we'll see here in the output here, it'll say detected abnormal stack frame exit at, and it'll show you the address where this happened, and then it gives you like information about the call stack frame itself that it had to pop off. So for instance, we see this 068A. If we actually put a breakpoint on that, so here we are, and if you recall, this was actually the instruction from last episode that was causing us the problem. It's this, it pulls from the stack the return address, but it just stores it into X and then it discards it, and then it follows up with a jump, right? So, and in fact, again, a little reminder, if we just look at the trace here, let me just inject some help. Okay. So if we just go up a little bit higher up here, we should see a jump subroutine. So here's the jump subroutine. And then instead of returning from it, it does this pull stack at S. So if I just step this now, you'll see that as soon as I step it, oh, and I wanted to show the backtrace. Sorry, I'll do that again. But it'll output that warning that I was telling you about. Detected abnormal stack frame exit at 068, blah, 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 blah. And then we're here. So after the pull S, we're at the next instruction, which is good. So let me just do another continue here just to show you again. I'm doing well. Thanks, Jono. Okay, so we just hit the breakpoint. Before I step it, I'll just show you the backtrace. So there's the first frame where we start, and then there's the second call stack frame, which is where we're in right now. We're at 068A in the stack frame that starts at 0796. If I step, we detected an abnormal one and we popped it. So if I show you here the backtrace, we're back in this first frame here. And in fact, you can see that this was, it'll show here that the frame was one that starts at 0796. That's what you see here, the frame value here. We were supposed to return to 022B, but we don't in this case. Instead, we continue, and at one point we're going to jump. I forget where, here. So this is like completely ignoring that return. So anyway, so basically all that to say is now we're working. and we are reporting when it happens, because I don't think we should see this very often, so I don't mind printing it. If it ever becomes like, painful, then I'll stop doing that, or I'll put it behind an option or something. I have these options, like option what to do with errors, my error policy. I could have like a policy for should we show abnormal call stack errors. Okay, so that's that. By the way, Jono, I received your email. I haven't gone through it yet. I've been extremely busy, but I will. I do plan on reading and watching your video to see your idea for this cool emulator you want to write. But yeah, sorry I haven't gone through that yet. Okay, so tonight we're gonna start basically implementing this DAP adapter thing there, this debug adapter protocol debugger thing. I'm gonna say debugger and adapter a few more times, but the main goal will be to start parsing the STAB format, because what I want to do is, like, there's gonna be like multiple phases to getting this debugger to work. So let me go here. Where did I put my stuff? Oh yeah, this is all related to the bug. I guess I could remove all this now. Get call stack tracking. I had a document where I had, oh, is it here? I will actually take a deeper look. I just kind of skimmed it, but I do need to read it and watch your video to really understand what you're intending to do there. All right, so this was the master plan, right? So just to repeat, make a debug build with -g so that GCC 6809 outputs STABS info in the output, so in these files. Vectrexy will parse all .rst files to gather all necessary debug info: source file, source to instruction mapping, variable name to address mappings, etc. Implement a DAP server debugger using CPP DAP, making use of the STABS derived debug info to return info and to set breakpoints and step, etc. So this is the part I'm going to focus on starting now. So here I wrote my first goal, and that's what I'm trying to do now, is just source line stepping, no breakpoints, etc. To be able to do this, we'll need to add the ability to track the call stack in Vectrexy. So that's done. And I wrote here, I think this should be simple enough. So this was when I first thought of how to do it. And then what else did I write here? Then do step in, over and out. I did this. So these, I guess I could just to show it, this is done. This is done. And this is what we're going to start doing now. We're going to start doing the parsing of STABS info, and then we're going to start implementing DAP. So I don't know how far I'm going to get, but we may as well get started. All right, so if we go here to my Solution Explorer. So right now what I have is I have this static library for the debugger. I'm going to put my DAP thing in here for now. Sorry, just I think someone turned on the vacuum. Okay, just 1 second. Hey, sorry about that, guys. Hey, Moosey boy, how's it going? All right. So yeah, so I was saying is maybe eventually I'll split out this debugger and I'll have like the CLI debugger versus the DAP debugger. But for now, I'm just going to mix it all in there because I need to reuse some of this stuff, and I'll figure out how to factor that out later. Oh, I'm good. I'm good. Thanks. So, okay. So I guess I'll get started with what? With a, let's start with the header file for this debug adapter protocol. So I'm going to call it a DAP debugger. Let me just do it like this. Open containing folder. I think I'll start by just kind of copying the same file here and renaming it to DAP debugger. All right, and then we're going to do the same thing for the source. So that's libs debugger source DAP debugger. Like I said, this one eventually will become like CLI debugger, just to make the difference, since I'll now have two different kinds of debuggers. So since I'm using CMake, I'll just generate the cache here. And we should see the new files show up in here. There we go. All right, so DAP debugger is over here. Yeah, most likely I'm going to need a lot of this stuff, but well, we'll get to it when we get to it. Whoops. Okay. So by the way, is the font size good for you guys? I think I used to run it at 120 or something. Yeah, I think I'll go to 120. Make sure you guys can read this. Okay. So yeah, so first thing I'm going to be doing is let's just go take a look at this Vectrex Pong over here. So the whole idea, right, is we're going to do, once again, run a task, make debug. So when we run make with debug, thanks, Jono. There we go. So that's, whoops, that's done. We go take a look in the output folder for Vectrex Pong. So one thing is I do need to like clean this up because right now it's kind of, I'm not like a Makefile pro or anything, so I need to make it so that, you know, when I build, right now it kind of like outputs all the files right in the root folder, which is really crap. Just to show you what I mean, if I like, sorry, like this, clean. So if I clean, so this is Vectrex Pong. You see nothing in the root folder. I have source in a source folder. Right? But my Makefile, like when I build, was going to, basically, you're going to see a whole bunch of files appear here. And what I really would like is for intermediate files to appear in like some, you know, intermediate folder and the output files somewhere else. I don't know. I haven't quite figured it out. Maybe make a build folder and put everything in there. But for now, it is what it is. It's fine. Okay, so if we look in here, what happened is that for every source file, for every CPP file, so 1, 2, 3, 4, 5 files here, there is a matching RST file. 1, 2, except for CRT, we can ignore that. 3, 4, 5. The CRT one comes from this CRT like assembly file. But for each source file, we're going to get this RST file. So the goal here is for me to start parsing those. if we open one of them, let's say this one here, main, so yeah, here's a RST file. You can see at the top here some information. It comes from the compiler, right, from GCC. It output this, so it's a fork of 4.3.6. Here are all the parameters that it used to build it, and everywhere where you see .stabs something, that's basically the information that we want to parse. Maybe not all of it, but you know, some significant portion of it. All right, so just thinking about how to get this started, we need to point. So right now I could sort of go like with this thing where we say, okay, you know, the ROM that we're going to run happens to be right now in the same folder as where these RST files are. So for now, I'm just going to go with that simple assumption. Obviously, if I modify the make file and move these into a separate folder, that's not going to work. But we could always augment the Vectrexy by, you know, telling it either with an argument or some config, you know, look here. Or maybe what I'll do is I'll say like, oh, you gave me this folder, I'll search this folder and all subfolders for RST files, maybe something like that. And then that should pretty much work for most use cases. But for now, I'm just going to collect RST files in the same folder as the ROM that we are running. So let's get that started. All right, so let's see. I think I got to go into my main. I have an engine client. That's where I have my debugger. So yeah, right now I have this. I'm going to have this kind of concept of two debuggers. I'm going to just manually, you know, disable one and just use the other one, I think. There's not much to do with a debugger here, as you can see. Init, reset, frame update, and that's it, all right? All right. So I'll have some init here. Yeah, I'm sorry, just thinking, what am I going to init it with exactly? Emulator. Oh yes, I can pass in the emulator, which we init with the ROM file here. Right. Maybe what I will do is start by telling it the same thing, the bias ROM file. Oh no, not the bias ROM file. What am I saying? Oh right, we do a load ROM. That's what we do. Okay. It's been a while since I've looked at this code. So we do a cartridge load ROM. Right, okay. So what I'll do for now is I'll leave this init out. What we will do is when we load a ROM, we'll tell the DAP debugger load symbols, and we'll give it the, I do load symbols, or maybe I'll just do like on ROM loaded or something. I don't know. Let's start with that. Okay. We're gonna need our loop. Oh, I guess we don't really need it right now. So we'll just start with this. Yeah. Okay, that's why it wasn't working. So now what I want to do is I want to collect .rst files in the same folder as the ROM file. So we're going to use a file system for that. Don't remember what this looks like. Right. I also have some file system utilities, right? All right, okay. So I think what we need here is some kind of path thing. No, I think I wrote some code for this in SDL engine. Oh yeah, there we go. So something like this. I guess it's not really current directory, it's the path to look in. So we'll create a path out of the file, and then we'll say remove file name. And yeah, so it's not quite the same. So what I'm going to do here is I need a way, what is it again? Directory iterator. Oh, that looks pretty good. Actually, is there a way to filter this guy? Or do I need to do my own filtering? Alright, I guess not. Okay. Okay, so if it's an RST, we're going to accumulate it into a little vector of paths. Okay, these are directory entries. So I'll just call it D. All right, so now that we have a bunch of RST files, we're going to want to parse them. I'll just say parse RST. I thought I would actually do it. Create declaration definition. It didn't do anything. Okay then. Okay, and for now, let's just see if this actually worked. We'll just print this. What's it called again? Console output. Okay. So let's see what happens. And I'm gonna change my, first let's see if it builds. Right. Doesn't like the FS path here, obviously. Build again. All right, and we're going to change our launch parameters here. So right now I'm pointing at Bedlam. That's not what we want. We would like the path to this Vectrex Pong, which apparently I had at some point, but then I lost. There we go. By the way, I really love this new feature. I don't know when they added this to VS Code, but basically when you paste a path with backslashes into quoted arguments, VS Code automatically, quotes, it automatically escapes the backslashes and adds a space. So like ready for you to put the next argument. I think that's pretty neat. And like if you undo, you'll see that you go back to what it had before it did that. You see? So very, very nice little feature there. Because I found myself often having to do like a search and replace of backslash with double backslash, so it's a little quality of life improvement there. Okay, so if we F5 here, That's not expected. Did I not? What did I? Unless I didn't pay attention to the output. Let me look again. Oh yeah, okay. It's because I thought I had disabled the old debugger, but apparently not. All right, so there we go. So parsing RST file, and we've got our base, BIOS, CRT, joystick, main, and vector list. So that's great. Oh, and even, no, that's it. Yeah. Good. Good for a start. So now we actually need to do the parsing. So let's go take a look a little bit at the file and sort of figure out what it is that we need. I think it's in here. Yeah. So what I need is I need basically everything related to source line location. So for every source file, I need to know the line and what do I need to know? Yeah, the line number, I suppose. Line numbers that represent the range of instructions. So like, for example, if we look here, yeah, I'm not sure I understand this here. I'm not sure if I should try to deconstruct it myself or if I should just look at the documentation. Yeah, let's look at the docs. Yeah, so the docs basically say that there are a few different types of STAB formats here. What they call directives. So there are 3 overall formats for STAB assembler directives, differentiated by the first word of the STAB. The name of the directive describes which combination of 4 possible data fields follow. It is either STABS for string, STABN for number, or STABD for dot. Then there's this IBM XCOF assembler, which uses STABX and some other directives such as .file and .bi instead of STABS, STABN, or STABD. So actually, that's interesting. I could enable this XCOF assembler output, but I don't think I did, right? And I don't know if I should. I'll see if I can get around without it. I think maybe the XCOF format gives a bit more information. Yeah, so I'm not doing anything related to XCOF. So let's say we'll just ignore that for now. So they're saying like when you see STABS, that's a string one, you'll get a string in quotes. Then you'll get type other description value. STABN is type other description. So you get like the last 4, but you don't get a string at the beginning for STABN. STABD, similar, but without a value at the end. I don't really know what a dot is. And then this is that extra one, which we can, for now, ignore. For STABN and STABD, there is no string. The NSTRX field is 0. See symbol tables. Yeah, we will see symbol tables. For STABD, the value field is implicit and has the value of the current file location. Has the value of the current file location. I see. So like when we see STABD over here, I'm going to zoom in a bit. Here. The value would be, I guess, line 813, maybe. Maybe. I'm not sure. Maybe it's 808. We'll keep reading. The other field is almost always unused and can be set to 0. Okay. 68034. Yeah, sure enough, the other field here is 0. So here at stab D, we have type 68, other 0, description 34. Okay. Now the number in the type field gives some basic information about which type of stab this is, or whether it is a stab as opposed to an ordinary symbol. Keeping in mind that stab stands for symbol table something. I forget now. It says it here. Symbol table strings. Okay. All right, so for each, so where was I? Or whether it is a stab as opposed to an ordinary symbol. Symbol table string versus an ordinary symbol. Yeah, I'm not sure what that means. Each valid type number defines a different stab type. Further, the stab type defines the exact interpretation of and possible values for any remaining string, desk, or value field present in the stab. See stab types for a list in numeric order of the valid type field values for stab directives. So let's see here. The following are all the possible values for the stab type fields for a.out files in numeric order. This does not apply to xcoff, but it does apply to stabs in sections. See stab sections. Stabs in ecoff use these values, but add this to distinguish them from non-stab symbols. Okay. The symbolic names are defined in the file include a.out stabs.def. So non-stab symbol types versus stab symbol types. So this is what they were saying about non versus stab symbols. So you have 0 to 0x1f and then 0x20 to 0xff. So if we go take a look. So here you go, non-stab types. The following types are used by the linker and assembler, not by stab directives. Since this document does not attempt to describe aspects of object file format other than the debugging format, no details are given. So probably we can ignore these. File external. They might be useful actually for us since we are implementing a debugger. We'll see. File scope data symbol, external data symbol. All right. Okay, okay. And then over here. So the following symbol types indicate that this is a stab. This is the full list of stab numbers, including stab types that are used in languages other than C. So we've got global symbol, function name. So if I look for 0x22, are they actually in hex? I guess they are. How am I going to find this? I wanted to find the first 22. Maybe like this. Looks like I'm not finding it. Oh, here we go. Is this no, this is not it. No. Anyway, no idea. Let's keep going. It's because we have here function name, and we also have function name. Oh, I see, for BSD Fortran. Yeah, I should probably pay attention. C procedure, so maybe it's 24 that I should be looking for. Nope. Data segment file scope, BSS segment file scope variable, name of main routine. 0x2a. Maybe these are decimal. It's possible, right? I don't see any hex values, so maybe these are actually all in decimal. So if that's true, maybe we'll be looking for 24 as 36. No, I think it's supposed to be the first value, right? Because they said it would be, the following are the possible values for the stab type field. Now type, oh no, type is the second parameter. No, it's the first parameter for stab D. Maybe it's stab S, I don't know. Let me see. Oh, here we go. Okay, so it is decimal. So in fact, it looks like it's stab S that we'd be looking for with a comma. There we go. So now we're starting to find functions. So this one here says main. I think F7 is like is function number 7. It is a function name. So I can identify this as a function name. So main F7 is a function name. Then comma, comma, and an underscore main. That probably says that's the symbol name for it. You know what I mean? Let's see. Function name here, symbol name for it. And you can see that the symbol name is pretty much the same thing without this colon F7 at the end. Yeah. So obviously I'm gonna have to do some name demangling for this to actually like look nice. But I don't know if I need function names. Do I need function names to begin with? Probably not. Yeah, that's not really important right now. What I really need are things like the mappings of, I think I'm going to need like these things, you know? Because if you look at the stab Ds in general, you know, like I'm highlighting up here, all of these with 68. So what is 68? Let's take a look. 68 decimal is 44. So probably the one that says 0x44. There we go. That's what we care about. Line number in text segment. Because if you pay attention here, this says I'm a line number symbol. I think it says I represent line 41 in the source code. That's what I think this is. And then it says for that we have 1, 2, 3. These 3 instructions represent whatever is at line 41. So let's go take a look at what that looks like. If we, how do I do this? Like this. Line 41, I guess not line 41, right? Oh, because I'm in the wrong file. Yeah, all right. What file are we in? So I guess it's going to be important to figure out the current file, and then for the current file, then parse. So this looks like it would be this guy here. STABS says we are now in source text.h. So let me look up 132. 84. Name of included file. Okay. All right. So if I open up text.h and we go to line, where were we before? Whoops. Getting lost here. All right, here we are. We were looking at this guy here. Ah, there we go. Something to do with character height. Line 44 was it? Or 41? Let's say here line 41. There we go. Okay, so this section here corresponds to the setting of the height. You see? It says we're at line 41, and when we're there, we're doing this instruction, and this instruction, which is the setting of car height times -1 into height here. And you could sort of see it. Load B 9S, negate B. So load into the stack the value at offset 9, so that's going to be character height because that came in on the stack. 1, 2, 3, 4, 5, probably offset 9. 3, 4, 5. So I don't know. Anyway, and then negate the value, which is what this does, and then store it into store the value in B at stack offset 1. So that's, and these comments are really helpful. It says here we're storing it into mdata.height. Okay. So let me see here. If I take some notes. So we look for STABS func name 36. So I'm going to here say 36 is, what was it again? Is 24. Function name. Wait, did I want the function name? I didn't actually want the function name. What am I saying? No, that's not the one. I wanted the include file. This guy here. I guess I'm gonna have to, define all of these. Now these are include files. Obviously, there's not just the include file, right? There's the current file itself, which is what I actually like to see what that looks like. Here we're doing main.cpp, so there should be a STABS for that. So what does that one look like? Is it 132 is the same thing? Yeah, see? This is not really an include file, so I don't know why they call it include files. SOL. Why SOL? Source line? Source? SOs for source something? Source location? I don't know. So here, this is not an include file, right? This is the file that we're in. Let's see what they say here. There are several schemes for dealing with include files. The traditional nsol approach, Sun's nbincl approach, and xcoff cbincl approach, which despite the similar name has little in common with nbincl. An nsol symbol specifies which include file subsequent symbols refer to. The string field, so this basically sets the current, file. The string field is the name of the file, and the value is the text address corresponding to the end of the previous include file and the start of this one. Text address corresponding to the end of the previous include file and the start of this one. To specify the main source file, use an nsol symbol with the name of the main source file. Okay, so that explains why they use it for the main source file. So that makes me wonder then, is that going to be true? Like, this is actually the main source file, right? But if I open, another RST here, like base.rst, are we going to find the same thing? Whoops. Yeah, we find the same thing. Okay, good. So it's looking like what we want to do is we want to parse, and when we see this STABS thing here, we're going to say, okay, we are now adding symbols for this source file. And then as we go through, we want to look for these 68 STABDs to tell us, is it 68, was it? Actually, I didn't even write that one down yet, but yeah, the one for the for source lines. So include file, and then 68 was 44, I believe. Yeah. Yeah, this one here. Okay, so yeah, what I'm thinking is we're parsing, we're looking for STABS. As soon as we see it, we say, okay, this is the current source file. Then we look for STABD, for STABD 68 in particular. And then that tells us that this next section corresponds to line 7, right? So let's go see. Push y in base.cpp. So let's go take a look. Okay, so there's a cert handler. Yeah, so that makes sense because you can see that we are actually in a cert handler here. And the first thing we do in here at line 7 is we have a label, and then we do push y load effective address -18 on the stack, store x 1, s. What does that correspond to? Somehow that corresponds to, I guess, what do you call it there? The prologue of this function, what it's doing, it's setting up the stack, it's getting ready. We're at the first, like if you were to put a breakpoint or if you were stepping, you're not right in the function yet. We're in the process of like parsing the args, you know what I mean, or loading the arguments. That's what this is about. Then we get to line 8, which is a call to Vectrexy printf. So that's going to correspond to all of this here. And you can see that makes sense, right? It's loading up into registers and doing a whole bunch of pushes. And then it does a jump. Hey, Reductor. So this is the 6809 processor. It's the one used by the Vectrex. And it was used by a few other systems in the 80s. There was one in particular, and I can't remember. That was pretty well known. So this is the one. So it was used in the TRS-80. That's the one I was trying to think about. So TRS-80, Vectrex, and then some early arcade machines like Defender, Robotron, Gyrus. It's a pretty cool processor, actually. All right. So I think with that, I should be able to get quite a bit. So once I know that I see a STAB-D, what I need to do is from then on, it's basically a state machine. I'm going to be parsing the next lines until I either hit another STAB-D or another STAB-S, I believe. Is that true? Let me just make sure, because I need to make sure I stop. So like if I take the last instruction here, so line 21, so if we look for a STAB-D where we end at 21. 23, so that's the closing brace. Okay, so that's actually probably 19. Okay, because this is an if statement with a break. Followed by 23, so this is the end. So let's see how this one ends. Right, so this ends with another STAB-S. 36. So I guess basically it's until the next stab. Now we may or may not parse it, but it's up until the next like the next STAB directive. So basically what we'll do is parse line by line. If line is a STABS directive, if it's a, what do they call it? Include file, nsol, set current file to it. If it's a NS line, then we start parsing the instructions, because basically what I want is I want to collect, what is it that I want actually? I don't really need this. What I really need is this here. So yeah, I need to collect, this is the address. In fact, I just need the address. That's it. So it's just the first token. Grab the first token, which is the instruction address. Stop at next STABS directive. Hey, local root. Wish I could continue to watch from the silent, but sadly it's already 4 a.m. here in Germany. Happy coding hacking though. Hope the archive will be there. It will be, don't worry. I'll definitely be uploading this tomorrow at some point. So thanks for watching. So I think with this, I should be able to gather the information that I need. The information that I need right now is simply source file and the line numbers that correspond to addresses. And in fact, I'm still not sure how I want to store this. Obviously, like we have consecutive line numbers. I'm still thinking about data structures here. Like, what is the right way to do this? What's like the most efficient way for me to do this? I mean, the truth is, we don't have that huge an address space, right? We just have a 64K address space. So I was thinking just like have 64,000, 64K entries. And then for each entry, have because basically when we're going to be debugging, we're going to be at some instruction, and the idea is map from the instruction we're at, the address of the instruction we're at, to the source file and line. That's effectively what I want to store, right? So a mapping of address source instruction address to source file line. So basically, easiest thing is just store an array of 64K entries. Yeah, that sounds right. Okay, so I'm gonna start coding on this. I'm just gonna go get some water, and we'll get going because I'm out of water. So I'll be right back. Okay. So actually, I was just thinking as I went to get water that, since I'll be doing this, it might be interesting if I actually made this not just available to the DAP debugger, but even to my CLI debugger, because I thought it could be kind of cool as you step. I could show, if we have this information, what source line we're at right now. That could be kind of interesting, and maybe it's a good way to validate this this work I'm going to do, because I guess I won't know until I get the DAP stuff going. So maybe this will be like an interim thing. So that's something I'm going to keep in mind. So to that end, I'm probably going to want to externalize all this symbol stuff. So okay, we'll get to that when we get to it. So what I was saying is most likely what we would like here is a what? We want file, we want line. We'll call that, I suppose, a location. I guess we could have very large files, extremely large source files. Although I think 4 billion lines is probably enough. What do you guys think? So file and line is a location. Cool. Great. So what do I want to call this? Debug symbols? Because eventually I'll have more than just locations in here, right? So in fact, I'm going to make this a fixed array of location with a size of 64K. What am I doing? Array. Something like this. So basically every time we add one, we're going to do something like this. Okay. I'm going to create an RST parser because I think I'm going to externalize all of this. Like I said, if I want to be able to use this from the other debugger, I'm going to want this externalized. So I'll start by breaking it up. So it's going to hold on to a debug symbols while it's parsing. And it's going to take a file. So I'm going to actually put this in here. Okay. Next. We're going to make a little state machine. And we're going to use my good friend. What is my good friend called again? Not tuple, variant. So we'll be looking for directive. We will be let me think here for a second. Yeah. Actually, I suppose what? I'm not sure yet. I'm going to iterate on this a little bit because I'm thinking I want to also detect if there's ever like an inconsistency. I think that when I'm going to say something, but probably I'm wrong. Yeah, I don't need this one. Looking for directive and parsing parsing line directives, I think. Something like that. Okay, now so now we need to start parsing line by line. I'm going to use std_get_line, I suppose. I think I've done that. Right. RST file. Actually, can this guy take a path yet? I don't know if F streams take paths. Do they? That would be really cool. Yeah, I think so. Looks like it. I want to open this in read format. I never remember how to do that. So C++ fstream read only. It's like iOS. Oh yeah, that's right. I know. So ifstream is for reading only. That's true. So this is already the case. Okay, cool. Yeah, likes it. Nice. Guess I'll keep this simple. I'll do similar kind of thing. Part of string. All right, so now this is where we do our special switch on our variant. I think I have a little helper for my variant somewhere in my base.h or whatever it's called. Yeah, base.h. Or I might actually have a special file for it. Variant. It's called overload. I think it is in base, right? Base. No? What is my overload? What's it doing? Oh, no. Stop that. It's like looking in Git objects. Did I not have my overload somewhere? This is very strange. Just give me a second. Oh, I guess I don't. Oh, right. I never put it in this project. That's true. Okay. So basically what it is that I want to do is I want to use std variant. It's very cool to use it for state machines. You'll see what I mean. But I need this thing that's not yet in the standard. It's basically it's called the overload trick or overloaded trick, and it's a way to use std visit but with lambdas. And the trick is over here. Not needed as of C++20, because I guess it's in C++20. So we're probably going to have to do something about that when we get to C++20. But for now, if I go into std util, yeah, I'll put it in here. Creates a type derived from the list from all t's, and brings in overloads from all of them. So this is a very cool trick, okay? So check this out. Basically, overloaded takes a whole bunch of types, like a variadic list of types, and it derives from them publicly because it's a struct, okay? And what it does then is it says in the body, it says, I want to, using the using declaration, it says bring in this, the call operator of each one of those base classes. So that's what this does here. Okay. So take those t's, their operator colon this operator, and all of them, I want to bring them into this class. Now, the reason why this is useful is that if you create a bunch of lambda expressions, those are really types, right? And you can create an overloaded type that wraps those lambdas, and that creates this new type that has in its body all of those lambdas call operators as overloads. So it's a bit hard to explain, but you'll see as I use it what that looks like. And in fact, this example is an example of how to use it. Like over here, you do std visit and you say overloaded, and then you give it a bunch of lambdas, you see? And basically each of these lambdas defines, by definition, an implementation of the call operator. Now, of course, the key is that each one of these has to be different, right? So like this one here takes anything. This one here takes a double, and this one takes a string. So then when you visit your type v here, v being some variant over here. Okay, it's a vector of variance basically, but you see here it's a variant. It's a vector of var t. Var t is a variant of int, long, double, and string. So this one has an int, a long, a double, and a string. So then as you go through them and you visit each value in the variant, it's going to visit the correct function based on the type. Now you're thinking you're probably thinking that looks pretty complicated, right? And like, why is this useful? This example is not showing you why it's that useful, because in this case, I mean, other than the fact that writing lambdas is easier than creating functions for all of these. But the key here is why it can be useful is that lambdas can capture. So if you have local state and all that, that's available inside these lambdas. So anyway, I'm going to use it and we'll see how that goes. All right, so overloaded. I think I put in std_util or something. Yeah, and I need to actually include it. Now, I actually need to do a std visit on this. And of course, for std visit, I think I need to include. Oh no, I think it's part of variant, right? Yeah. I mean, this may be more complicated than I need, but we'll see. Okay, so while we're looking for a directive, what we're going to be doing is, let's see, we're going to parse our line. So now I need some line parsing. I'm trying to think what's the best way for me to do this. I'm going to maybe use regex here to try to parse out my information. Although for stabs I can just do like a search, simple search. I don't really need regex for this. Oh, actually, yeah, I think I will do a regex because I want to extract these values here. Yeah. Just to make sure, yeah, I've got the right thing. Okay. Looking at the clock, starting to run out of time here, so let's see how fast I can go. Std regex. Probably have some in my code base. Let me see. I even have a regex util. Oh yeah. Interesting. I don't even remember what I did this for. But let's see, find. No, I didn't do too much of it. What was it for again? Oh, that's cool. Let's call this source file RE. How about that? Okay, so what does that look like? Oh, that's cool. You can ignore case. Let's see, regex, word regex. Yeah, okay. And then just captures. And you have to escape the backslash. Okay. So what are we looking for? So we're looking for something like this, right? We're saying, let's move this up. STABS, followed by, what was the white space marker there? No, that's word, not white space. Just wondering if we can get some. Is it like WS or something? /s. I want to know like the C++ regex white space. /s plus. No, for C++. I guess it's this one here if I use the ECMA script syntax. Oh, there we go. Yeah, so /s. Okay, same as space. Almost feel like I should maybe use this because it's like more clear. Yeah, let's do that. So we do something all the way up to .stabs, then we follow with a space, then we capture the source file, right? So that's going to be quote. In fact, do I want the quotes? Until the next quote, comma, to be honest, I can kind of ignore the rest. So after I've captured this and I've captured this one here, I can just ignore the rest for now. No, you know what? I'll capture them. And in fact, I will capture it with the quotes, and I'll remove the quotes later. Yeah. All right. One, two, three, four, five. 1, 2, 3, 4, and one more. Of course, I am assuming that all 5 will be there, but it looks like that is the case right now. That's a source file regex. If this is correct, then while we're looking for a directive, we're going to try and do a match on that guy. So there's regex search, but that's not the one we want. I think we want match. Attempts to match regex expression to an entire character sequence. Attempts to match regex expression to any part of a character sequence. Okay, so I think it's the match. Right. So S match is a sub match. Is that how we're going to get the groups? If we match, base match, base regex, the first submatch is a whole string, the next submatch is the first parenthesized expression. Okay, this is just like in Python. Line, the match, and the regex. If this return true, then we found a source file, so we want to set basically the current source file. So this is where it gets somewhat interesting is that while we're doing parsing line directive, we're going to tell the state its source file. So state is going to become equal to parsing line directive, and we're going to extract the source file from the match. I'll put it on a separate line just so that we see it. Okay, so that changes our state into parsing line directive. So what does it not like here? Directives, right. All right, and here I'll say okay, so once we've seen that we have parsed the source file thing, we're now going to switch into parsing line directives. And while we're in that state, we're going to look for STABD. Actually, is that what I want to do? Let me think. No, that's not quite right. Okay, yes. So what we'll do is we'll do like this, st.sourceFile. So the current state, which is looking for directive, will set its source file to the value of the match. Okay. For some reason, it doesn't like match. Oh, dot string. I see. Okay. Is that right? No? Base submatch.str. What doesn't it like about that? Oh, okay, I have to extract, okay, from the submatch. Yeah, that's what I'm doing. Oh, because it's const. All right. Okay, so we set the current string, and then we remain in this state. The next thing we're going to do is we're going to look for the next regex that we need would be for those line numbers. So like this. This is similar. We're gonna do dot star. In this case, it may not even be white space. This is 0 or more, right? Is this? I put space here. I actually should put a star on it, right? I should probably make sure this even works before I do this one. Let's do that. I forgot to pass it the second parameter, which is state. Is that what we want? Ah, yes. This is not a function, it is a type that we're creating. That is gross. Let me see if this is some Clang format nuisances. If I do this, will it look better? No. A little bit better. Not much. Alright, let's just go with this for now. This is where Clang format is failing me. I would want this to be like aligned this way, but Clang format won't have it. No matter what I do. See? Oh, if I do this, it works. It brings it up there. Shenanigans. Okay, let's just go with this for now. Okay, so let's see if at least we hit this regex match. We may not, but if we do, then we should have our current source file as we parse. And what we'll do is we'll even print it. How about that? Can we do this right away? Yeah, so you know, if you're ever used to using a formatter, especially an opinionated one, sometimes you find yourself having to deal with garbage like this. And you just enter extra white space and comments and stuff, and you hope that you can trick the formatter into giving you what you like. On the other hand, you know, for the few times that I have to mess around like this, I really do love not having to do any more like manual formatting. Do you know what I mean? So, okay, it doesn't like my backslash. Oh, is it because I have to escape the backslash? I think so. I think there's a way for me to do this with raw strings. Regex raw string. Right. Is that better? It's actually R quote open paren. Very confusing though, because this closing paren here looks like it's part of the regex. All right, unreferenced role. Yes, that is true. We are not yet using this, but we will. Unreferenced. Yes, thank you very much. All right, looks like we got a build here. So let's just go for gold and see what we get before we debug it. Did I not have code that like called into my symbol loading thingamajig? Oh, I removed it. that would explain it. All right, so let's create a RST parser. And we will initialize it with a debug symbols. I'll just call this symbols. And address of symbols. And parser.parse. Let's try that. What you talking about? Oh, right. It takes it by ref. Okay. Let's try it again. Okay, so we got a crash. Why? Why we get a crash? On ROM loaded. Okay, that's good. Do I? What's the problem here? This will be easier in debug. Okay, so it's complaining because my debug symbols here allocates a large number of values, and this will exceed the stack. That's really cool, actually, that it does this analysis. Huh, very interesting. That's probably what happened. Actually, let me just see it, that I should get like a stack overflow or some kind of stack check fail in debug. Very cool analysis. Visual Studio's static analyzer. It's pretty cool. Stack Overflow. There you go. Okay, sounds good. So to fix that, no problem. We'll include memory. We will unique pointer our friend here. In fact, what we will do is we will make unique. That's better. Okay, let's try again. Cool. So we got something, but it does not quite look right. So yeah, of course, I did not parse to see that I actually got the right code. But I am regexing, so that's cool, right? This looks good. It's got the quotes and everything. Very nice, very nice. All right, so I'll switch back to release because it's faster here. Okay, so let's say we match this, right? In fact, I guess I shouldn't call it a source file RE. I should call it a STABS. All right, let's call it a STABS RE because that's exactly what it is. We match a STABS if the match, I guess it's 1, 2. One, 2 is equal to, so 132, what was that, our friend again? That was our, it's this guy here, nsol. I have to say, I don't really understand what NSOL stands for. I guess it's source, name of source, something. And they call it name of include files to make it even more confusing. Okay, so let's try this. Right. This is a string, isn't it? Yeah, okay. Let's S2I that thing. Actually, that's not going to work because S2I assumes decimal. And I need to tell it what base it's in. How many overloads we have here? Index 0, base 16. Is that what this is? Yeah, I think so. I think I used this guy somewhere else. Oh no, wait. What am I saying? It is in decimal, right? Yeah, it's decimal. We saw it here. The file says 132. So yeah, so I was gonna work. Jumped the gun there. Okay. I'm looking at the clock, 11:08. I want to wrap this up soon. Okay, look at this. This looks pretty cool, right? So when we're parsing base, we get base, Vectrexy, base CPP, Vectrexy header, and text header. So I guess it makes sense. Most of the time, it's going to be include files that we're parsing. they make a special exception for the main file itself, which is in this case base. Later on, we're doing BIOS RST. That guy similarly. Interestingly, this guy here also has BIOS CPP. Oh no, sorry, not base, BIOS. Yeah, that makes sense. And then base, and then BIOS again. Nothing from this, not a surprise. This looks good. And then main has a whole bunch. Vector list. Yep, that looks good. Cool. So that works. Hooray for parsing. All right, let's quickly try and get some line numbers in there. It would be really great if I could just get some symbols going there, and then in 2 days we can work on actually using this. So for this guy, we're going to start by looking for, again, .stabd. So this we're going to call it stabdre. So it's a regex for a stabd entry, which has stabd. I guess I don't need this. Do the same kind of thing that we are doing here. Then we're going to look for space, and I think it's exactly the same except with one less, right? 1, 2, 3. 1, 2, 3, 4. Actually, 2 less. Like this. So that should be our stabdre. So if we match a stabd, we want to see if it's number 68. So let's go get that constant. So if it's a line number, then the actual line number is the last value, right? So we say let's print it. Okay, let's just start with this. It's exciting. Okay, not getting my line numbers, so let's see why. So here actually there's spaces in between. So to make this more generic, I really should be putting after every comma, 0 or more white space, even on the string ones, even though the format in this file doesn't look like that, just to be pedantically safe about it, I'm just going to do this. And now I'm sort of feeling like I want to use /w because it's starting to look kind of ugly. But okay, so let's say like this. Okay, let's just see if this works. So you see, I noticed there's white space here, but not on these lines. Still no good. Okay. Oh, wait, there's no comma here, right? Wait, sorry. Stab D space. Oh, no, sorry, that's wrong. Okay, so then I capture the this guy here. Regex. What do they say about regex? You have a problem, you solve it with regex, now you have two problems. You can see it happening before your eyes. My white space, this is my first capture, comma, 0 or more white space. Right? Then a non-white space capture, comma, 0 or more white space, and then a non-white space capture. This closes the thing. This looks correct to me. All right, let's debug it. So close. Yeah, so this is gonna take a while. So let me do something here. What's the file that we're parsing right now? Line file is file. No? Anybody? Ah, okay. Base. Let me just do something here quick. I'm just gonna grab one of these, stick it right at the top. There we go. That's gonna make it easier. Okay, so there's our line that we are supposed to match this time. And, oh, okay, so we did match it. So maybe it's just my, oh, right. Haha, yeah. Yeah, my bad. This should be 1, this should be 3. Just see. And line number 61, that looks correct. Yes, indeed. All right, so let's kill this. Let's revert that. Let's run the whole thing without this breakpoint. because I gotta stop now. Just want this to work. Okay, just gonna break right here. Hey, that looks pretty good, right? Let's see if we can correlate this to what we have in our source file. So if we come here and we're parsing, let me close some stuff here. So we're parsing base. Okay. Source base.h. So let's open base.h. Line 45 must be memcopy. And then it should start at 53. There's 53, 54, 55, all the way until 64. After that, I guess we're going to do one at 66. Actually, it might be useful to spit out the functions just to know what function I'm parsing right now. But it's not technically important. But this looks right. After that, 72. Then looks like we go back to Vectrexy.h, 61. See, it all depends on what's being used, right? Because right now we're doing base.cpp, so it all depends on what the compiler actually picks up for its lines of code. See, this is base CPP, line 7, all the way to 23, which corresponds to our function here. And some more Vectrexy.h stuff. Curious, actually, what is it picking up from Vectrexy? So the first time was 7 to 23. 7. No, sorry, 61 and then 71. 61. Because we're doing a printf. And 71. So these two push args, one for a UN16 and one for a const char star. Because you see, if we go back to base, see, we're doing a printf. There's our const char star, and we've got a few for, at least for, no, it's two const char stars and one for a size t, which in this case is a UN16t. So that's where that's coming from. And then we've got 89, 90, let's see. And the call to printf itself. Cool. Okay, guys. Well, this looks like it's working. So, actually at this point, it's not very difficult. So what we'll do next time is we'll continue from here. But the idea is when we know that we're parsing these guys, we, once we have parsed a line number directive, we want to switch state, and now we want to just start parsing all instructions until we get back to a directive. You know what I mean? And when we go back to a directive, we go back to this state here. So something like that. And then as we parse those addresses, right, in between, just open that file again. So for instance, we'll parse here. While we're parsing all the things in between this and the next stab, we'll take this address and we'll say add an entry for the current location, which is source file and line, for this address. And then by the time we're done, we will have filled up a whole bunch. Presumably every location we could step into, except those that don't have source or symbols for them. And then that will allow us to start emitting source and file, right? Okay, so I think I'm going to stop it here, guys. Thanks for watching, and if all goes well, I should be streaming again in 2 nights. All right, take care.